All right, Dean and Gavin, if you're just joining us, here's the debacle that just happened in CalcBC today. Long story short, homework 40 is what was supposed to be due today on section 9.4. Sadly, I never put a due date to it, so I just thought I hadn't put up the homework, even though I had. I just hadn't made it due the correct time. And so I added accidentally the next homework, which is the one due on Monday, section 9.5. Some kiddos accidentally did the problem numbers to this one with the correct section from notes yesterday and the day before. And so I'm just having them kind of compare how many they did from each and do a couple extra if there aren't the same number of problems from the ones I particularly selected for homework 40. And then I had some kids actually trying to do homework 41 when they weren't ready yet. So just, if you did that, hold on to that. It's due on Monday. You'll learn how to do it and do it well. So my advice is to unsubmit 41 because you shouldn't have submitted it yet or done 9.5 yet. It's the notes we're covering today. Section 9.4, I was going to say due by midnight tonight, but I'm changing it to 8 a.m. in the morning just to give you a whole nother day to try to figure out what to submit. If the problem numbers are a little off, it'll be okay as long as you did adequate practice as indicated by the ones and the problems I selected. If you have any questions, ask me separately and we'll figure it out. And also, there was a missing homework, a missing problem from 9.3, number 71, that I had attached, but once again to the wrong homework. So now number 71 is in there for you guys to access, for you guys to be able to use and to see and to finish homework. Okay, I'm picking back up with the class. They were talking in their groups, trying to answer any individual questions about what they did for homework and how they messed up. And then we'll see where we're at. All right, guys. So thank you for at least trying to get each other on the same page. Are there any questions I did not address? Or any explanation, clarification as to what will give you 100% in Google Classroom now? Yes. Any other questions? Okay, right now, homework number 40, I did have it due at midnight. I've gone ahead and made it due at 8 a.m. tomorrow morning. That way you don't even have the midnight deadline. I'm giving you a whole other day to get it in. I now have attached in the proper homework number 71 from section 9.3. So you guys can access that if you were like, where is it? Last night. And for those of you, once again, that did the correct section homework, if you did section 9.5, just pretend you didn't because you didn't know how, and I don't know how you learned how. And just, we'll learn, and then you can do it the right way. No, there might be more. There might be more. So, I mean, you guys could have, like, played it chill and not, anyway. And if you did the section 9.5 problems on 9.4, I think according to Lorenzo, you just need to do a couple more to make them even, and do a couple more that you didn't do from the ones I selected. Don't like pick your own random ones. Go find ones that you didn't do that I wanted you to do, and do 2 or 3 at the end, and that'll be fine. To that end, let's get out of Google Classroom, because to be honest, I am so tired of it by this point, and let's get back into notes. Yay, something I'm used to. So we're not going to grade homework right now because, to be honest, we've all done different things, it seems like. So it might not be profitable to be like, what were your questions? Because you're like, how do you do 9.5? Okay, let me answer that. Let's work on 9.5. Let's work on 9.5. And then tomorrow, by 8 a.m., you guys can bring me the problems you did in section 9.4 that you are stuck on. Sound good? Yeah. Okay. And I'll just be ready to answer all of them. Or at least the ones that are most important for us moving forward. Meaning if you did some random problem from like the weird concept-y at the end because it was assigned in 9.5, I might just be like, wasn't really important, so we're skipping it. Okay. Alternating series. Let me zoom in. Alternating series. Alternating. Going back and forth. Hey, that's the guy we couldn't do up until this point. We could do it if it was completely positive, to some degree, maybe the comparison test. We could do it if it was completely negative. My couple people that kept on trying to be like, what if it's all negative? My advice, factor out the negative and then say it's all positive. There you go. Yes, you can. But what if it's back and forth? Integral test fails, right? Positive continuous decreasing, looking at the function comparison of the nth term. Comparison tests fail because both of them need both of them. Both of them need positive terms. I think so. Direct comparison is positive only. Limit also? Okay. Limit comparison is positive only. Nth term test. Well, actually, maybe that one's okay. Geoseries. Actually, that one can be negative because R can be in between 1 and -1. So geo could have been an alternating. Nth term could be an alternating. What else? P series. No, P series couldn't be alternating because P series is 1 over n to the P. N is a positive integer as denoted by the bounds of the summation. And a power of a positive number will always be a positive. So yeah, no, P series fails. An integral test is not applicable and comparison tests aren't applicable. So we have very few times right now that we can do alternating until this test. Abby, I'm sorry. What's up, kid?
It says the alternating series, the first summation, is it supposed to be a -1?
Oh, it's supposed to be equals, Mom. Thanks, kid. The bottom part of the equals, for some reason, sometimes when I steal stuff from like PDFs or Word documents, some of the little pieces end up disappearing. Let me make it as thin as possible and see if I can throw him in. Good catch, kid. Some of you guys saw it, but it's always helpful when someone brings it to my attention. That way we can all be on the same page. Ooh, Google Classroom last night. Huh.
So aren't we just copying the same, like, summation formula twice?
Well, both of them are from 1 to infinity, and right now both of them have -1 to the n, a to the n, but I was actually going to adjust this second one to go ahead and throw n plus, oh, it's too thick, let me make it thin, n plus 1. And here's the reason why. It doesn't matter whether the summation starts with a negative or starts with a positive, it's just the fact that it alternates. So -1 to the n is going to start with a negative, because -1 to the 1. -1 to the n plus 1 is going to start with a positive. And here's something else for you guys to realize. This is not the only way that alternating can show up. This is not the only way that alternating can show up. Keep your eyes open today if there's any other place or any other time that a series could be alternating without having a -1 to the something. But this also shows you guys it could be -1 to the 2n or -1 to the 2n plus 1. Something where -1 is raised to a power which is going to alternate between positive and negative, which means the sign resulting will alternate between positive or negative. What does it say? Alternating series will converge if both of the following are true. The alternating series will converge if both of the following are true. This entire section, one test, but we have some special adjectives and some special, I would almost say corollaries, even though this isn't specifically a theorem. Thank you, Mr. Hampton. Shout out for saying that our geometry program isn't doing a good job of you guys knowing postulates and theorems. Corollaries, but anyway. He taught you, which is good. Corollary is like a sub, right? Like a sub theorem that comes from, sort of, the original theorem. But coming back, something about Teddy Roosevelt carrying the big stick compared to Wilson. Was it Roosevelt versus Wilson? Was it you guys? What was you guys? No, he said about seniors, wasn't he?
He was not. Maybe it was
Oh. Yeah, okay. Anyway. Corollaries are like kind of like subplots or like sub-theorems. Like there's a theorem and the main theorem, and then a corollary would be something that came up later or something that was amended later or added to it later that is also true. So alternating series. There are some other things that are coming. Let's just get the main test down for today, hopefully. The limit has to be 0 of, wait a minute, the limit of what though? The limit of the whole thing? Just the nth term disregarding the alternator. Okay? So the limit of the, if you guys want to put it in words, the limit of, and this is not a very mathematical term, but I think it gets the point across, of the non-alternator. Anybody know their cars very well? What is an alternator? In a car. All right, robotics club. It's your job to figure out what an alternator does. Coming back. I'll ask you tomorrow. I'll ask you tomorrow. You should be digging into machines, and I know it's a little different with programming, but still, dig in. What's an alternator? Now, coming back. Come back. A non-alternator. I'll ask you tomorrow. A non-alternator. Basically, the -1 or whatever else is causing the entire series to go positive, then negative, then positive, then negative. That needs to be disregarded for step 1. We're disregarding the alternator. We're just looking at what's left of the nth term. Now, I'm not just going to say ignore the -1 because I've already said other things can cause signs to alternate. Some of you are already pondering and thinking. I'm curious if you can come up with one, and I'll ask you in a second, giving everyone a chance to think. What else could alternate besides a literal negative number raised to a power? But also, you need your term, regardless of the alternator. You're disregarding the alternator for both of these. The limit of what's left, is it 0? And is the second or the next term smaller than in magnitude, basically, because we're disregarding the sign, less than or equal to the previous term. So remember, in this one, a sub n plus 1 is the next term less than, that's greater than. Less than or equal to the previous term. What's another way of saying that? It's not strictly, but it could be at least somewhat decreasing. Does that make sense? As you go on, it's going to get smaller and smaller, or at least be equal to. It's getting smaller, or at least equal to. Or at most, maybe I should say, equal to the previous term. So you can think of it as decreasing, although I don't necessarily want to say that term or say that word because it's not always going to be less than it could be or equal to as well. And then, wait a minute, why can I say the series diverges if the limit of the nth term is not 0? Technically, it failed the nth term test. Exactly. Technically, it failed the nth term test. So it's saying, hey, with alternating, we can say that that basically failing the nth term test causes divergence also. So it's kind of bringing in this alternating series and saying, yeah, any series whose limit is not 0 is going to fail to converge, aka diverge. So we have our terms alternating in sign. If the terms are eventually decreasing, they can't stay equal all the time, but they are allowed to sometimes be equal to. And then here's the idea that sometimes it might take a while to figure this out, so then write out the first few terms to try to figure out what's going on, especially with unfamiliar functions. We've talked about -1 raised to powers, whether it's n or whether it's -1 to the 2n plus 1 or whatever it might be. Has anybody thought of any other alternatives? But you can't just tell me sign, you can't just tell me straight, because I am plugging in integers. Sine. And so even though sine or cosine or tangent, in a really awkward way, could be an alternator, you can't just say sine of x or sine of n, throwing that in, because if you just throw in sine of n, sine of 1, sine of 2, sine of 3, you're going to land in all different places of that sine curve. It's not going to strictly alternate, always positive, then negative, then positive. What would you have to do to sine or cosine to make sure that it inverse? What's pi over 2? Cosine or sine? Lorenzo's trying to say pi over 2, and I'm assuming you mean times n, but who would need to be cosine? Sine. Why? What does sine of pi over 2 equals? 1. What's sine of 2 pi over 2? Uh-oh. No, that's 0. That didn't work. I like the idea, it just didn't work. It's not letting us stop off at 180. So now I have pi over 2, but not 2 pi over 2. I have pi over 2, then 3 pi over 2, then 5 pi over 2, then 7 pi over 2. Wait, sine is 1, then -1, then 1, then -1, then 1, then -1, then 1, then -1. That's an alternator. What would we have to do for cosine to make it an alternator? Every pi. Cosine of 0 is 1, cosine of pi is -1, cosine of 2 pi is 1, cosine of 3 pi is -1. Good. So I need you guys to realize it's not every time sine or cosine is present. Like, just because sine is there, just because cosine is there, doesn't mean it alternates back and forth between positive and negative nicely every other term. It would only be sines of certain angles and making sure that we're only looking at those angles, or cosines of certain angles, making sure we're only looking at those angles. Tangent is awkward. I've never seen them use tangent as an alternator. But tangent could be pi over, no, could be pi over 4, which is equal to 1, plus pi over 2n. Could be pi over 4 plus a half is 3/4 plus a half is 5/4 plus a half is 7/4. So that would work. Because then it'd be 1, -1, 1, -1, 1, -1. Anyway, I've never seen them use tangent as an alternator, but it could be made to be an alternator too. Okay. We have two things that need to be true. And whoa. Hey, little buddy, you're not supposed to be there. Okay. There we go. If you have a convergent alternating series, now if it's divergent, like you're done. Okay, good. If you have a convergent alternating series, there are two different adjectives that can describe the type of convergence it has. And this is where it gets a little messy in the sense of like, wait, we've only had the answer convergent or divergent. Why do we now have the answer with an adjective? Sometimes you don't have to. Sometimes you don't have to. Unless the AP explicitly asks for it, unless a question explicitly asks for it, I'm not requiring you to go into depth of what type of convergence. But there are questions that will specifically ask you as to which type of convergence it has. For some reason in my head, as far as an analogy to this, could be something like when you mark, let's assume that you're actually marking it correctly and that you're being fully honest and not just choosing not to reply. When you mark your race, your ethnicity, I forget exactly how they do it, on like an SAT or on like an AP score or an AP test, right? Now you can choose not to put it down, so we're not going into that. But if you do choose to put it down, what do you guys put? Okay, they're very general categories, right? Maybe like Pacific Islander or something, isn't that one of them?
I used to have to.
Oh, do they have multiple different Hispanic ones now?
For Hispanic, they ask a specific question for which type you are.
Oh, that's new. They didn't used to have.
I used to have Latino.
All Latino places, and then it's after that, sometimes you have to choose another thing. It's like that with
Yeah, it gives like.
Okay, but this is exactly what I'm going for. Because technically, it used to, like, before it went into the subcategories, if you were Hispanic in some sense, like, what was the actual box that you would check? Just Hispanic, right? Or Latino, Latina. Okay, so you would just check that box. But, question, if you talk to someone who's Hispanic, isn't it pretty important to most families what type of Hispanic? Like, where you're from? Like, I'm Argentinian, or I'm Nicaraguan, or I'm Guatemalan, or I'm from Mexico. Like, those are very different depending on your family. And even, like, some kids, I don't know, it's like the first year of the merge, but it was something where they would just get highly offended if you called them, not you as in me, but like other kids being like, I'm not a Mexican, I'm whatever, or whatever. Like, it was very, or like if you were a Spaniard versus, European versus like Latin American versus South American, okay. But there is a context where it's like, no, this really matters. But then on the SAT, it used to be like, well, I'm not any of those, I'm this one. Like, okay, it's general. That's kind of the idea here in the sense of like, okay, it's convergent. Like, done. I checked the convergent box. But then it's like, wait a minute, what if it sends you off to, thanks David, what if it sends you off to this other, like, okay, well, what type? That's kind of what's going on here. And if you want to think about it, why am I bringing up ethnicity and like your family and your origin and where you came from? Because that's technically what these two words are all about. Where is the convergence coming from? Okay? Where is your convergence coming from? It's very similar in the sense of like, okay, I'm Latino, I'm Latina, I'm Hispanic, but what type? Where are you coming from? I'm Asian, okay, but there's many different. Where did you come from? Does your family come from Korea or from Japan or from China or from the Philippines or from India, right? Like what kind of? There's a lot of countries in Asia. So, I know this could send us into a million different directions. And anytime anyone in chapel ever says anything, I know it can send you in a million different directions as well. But there's a time and a place to just be like, okay, I get it. I could talk forever about whatever I want to, but we need to focus. So here we go. Both of these adjectives are, where is the convergence coming from? Absolute means the alternator didn't matter, had no effect. It would have been convergent anyway. Absolute means the alternator had no effect. It would have been convergent anyway. Conditional means it is convergent because of the alternator. Okay? So literally, these are saying, why is it convergent? Where is the convergence coming from? Ultimately, like the concept behind both of these, absolute says, regardless of the alternator, whatever it was, the negative 1 to the power, the sine of pi over 2 plus pi n, or the cosine of pi n. Cosine of pi n is more familiar or more commonly repeated. What am I going to say? More common. Conditional convergence. It's convergent because of the alternator. Okay, let me illustrate that for you. I know there's some more notes here, but let me see what example I have on the next page. Yeah, that works. Okay, we'll come back. It's okay. We'll come back to, like, you guys can fill in the notes, whatever. But here's a great place for this example right here. And specifically, let me write it bigger. We're trying to determine the convergence of n equals 1 to infinity of negative 1 to the n plus 1 all over n, which another way of writing that would be n equals 1 to infinity of negative 1 to the n plus 1 times 1 over n. If you've been doing this, your brain should be like ding, 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 1 over n. I was just waiting until all the eyes were on me. 1 over n converges or diverges? Diverges P series. P is equal to 1. It's that special simple harmonic series. And he diverges. But the problem is there's an alternator now. Well, it's good and bad. What are the two things? You have the test written down. What are the two things that need to be true for an alternating series to converge? Wait, why am I only looking at 1 over n? Disregarding the alternator. Good. And does it equal 0? Yes. If it didn't equal 0, I could say forget it, it's divergent, but it does equal 0. But wait a minute, nth term test, that's not enough. Well, number 1, I know that's not enough for nth term, but I have an alternator, and that's the first step that needs to be true. But there is a second step that needs to be true. What else needs to be true? If I literally plug in and go one term in the future, isn't it literally 1 over n plus 1? And is that always going to be less than or equal to 1 over n when I'm talking about positive integers from 1 to infinity? Yes. So question, what does this series do? Converge. Now, old days, check the box, you're done. Some problems just care about convergence, and you're like, yes, it's convergent. Dun, 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 dun. But some people are like, I care about how it's convergent. So how is it convergent? Would it be convergent on its own, disregarding the alternator, or is it convergent only because of the alternator? Absolute or conditional? Conditional. So in parentheses, if the extra menu ever opens up, it's conditionally convergent because it's only convergent since it has an alternator in it.
So you know how you think the limit 1 over n? Is there ever a case if you were to take them with the alternator? Like, can you take the limit with the Does it ever matter? Like, what is the if 1 over is a... Depending on what the alternator is, it might, like if it was like a cosine of pi n. You still go to the other things. I see what you're saying. You're saying why is there... I think it's mostly for a simplification of the process because we've never taken limits
of, it's not that I remember, oh no, there could have been a negative one to that. You were introduced to some this year, and last year you barely saw it. They started introducing it early so that you would be somewhat familiar with it. So to some degree, based on your understanding, informal definition of a limit, to be honest, without the epsilon delta proofs, I don't think it'd be a big deal, and most of you would be able to take a limit even with the alternator. But if they were asking for a formal definition of the proof, I think an alternator makes it way more difficult with the epsilon delta proofs. And so ultimately it's allowing you to avoid that complication, if that makes sense. But technically, since we need the limit to be 0, and in your head, even if it's alternating, as long as it's going to 0, we'd be okay. I think it's more that alternators can be messy, and so it's allowing you to ignore the messiness. Yeah. And with your informal understanding, it's like it's not a big deal whether or not it's alternating, whereas someone who is a few years or a few levels down the line might be like, oh, alternators are so much worse to actually prove why the limit is what it is. There is another example that we'll zoom in on in just 1 second, but I wanted to just show you the idea of conditional convergence because this guy without the alternator is most definitely P-series failing to be convergent and is divergent. But let's come back to this side over here where we were talking about the adjectives. Oh, this is super annoying, but I can't just let it all. We have over here the definition of absolute versus conditional convergence. I think I forgot to label the forever card, and I'm not sure if I've been labeling all of the endeavor cards along the way. But this one is, there we go. This one was which one? 20? Kevin thinks 20. Can anybody back him up real quick? Oh, just kidding.
Oh, please.
What is it? 18.
18.
Wait, did you get direct and limited comparison?
Yeah, direct was 18, limited 19. And then
Oh, so this would be 20. I'll get them on Google Slides just to make sure that everybody or everything is looking okay. But
You have direct comparison.
there's direct comparison, limited comparison, telescoping. What was that one? Oh, okay, so telescoping is 19, limit is 20. This one would be 21.
What? Limit comparison.
I'll get an update on Google Slides this afternoon. That way you guys can check it out. This would be 21, and then my absolute and conditional convergence will be 22.
I just got my number. I just put
Absolute convergent is saying the absolute value converges, which means regardless of the sign and the alternator, we are completely disregarding if we're saying absolute value, we're looking at the nth term apart from the alternator. So if it converges, then you can say absolutely convergent. And then if it would diverge otherwise, then we just say, okay, it's only convergent based on the alternator. That's the idea behind it. As far as the strategy, the hard thing is if they ask you for absolute or conditional, you could go looking for absolute, and if it converges, you're good. It's absolutely convergent. But if it doesn't converge, you have to go looking at the alternating series test. You could go looking at the alternating series test right away, and then go backwards to absolute convergence. You guys will just kind of feel it out as you're needing to sometimes throw that adjective in as to which would be more strategic or which would be easier. And that's kind of what I'm talking about down here in that you could go looking for absolute, but if absolute fails, well, we could say if it passes, then absolutely convergent and we're done. And it was like, well, that was the shortest, most efficient way of getting there. But if it fails, now we have to go do the alternating series test. Kind of like the second derivative test for relative extrema. If it passes, if we have the second derivative equal to a positive or a negative at a critical number, we know that there's going to be a relative max or min. But if it fails to work, we have to go back and do the first derivative test anyway. So it's one of those, if it passes, you get to avoid it. If it fails, we have to go, and we kind of just did 2 tests when you might maybe only had to do 1. So the other way is that you could just always test for divergence first. Just always go looking right away at the limit as n goes to infinity of your a sub n. And if this one fails, in the sense of if this one equals some sort of limit that is not 0, then right away I can say divergent and I could be done. But then if it equals 0, we just have to realize we technically know nothing until we realize it's an alternator and we check for the second step. And then we would still have to think about the absolute value after. So there are different ways with these alternating guys as to where you start. I'm going to probably just kind of go back and forth with how I start. Some of it's based on me just being able to look at it, and maybe some of you will be able to do that also, like make a quick hypothesis as to what we think is going to happen, so we head that direction until we get turned around and say, nope, that's not the right direction, go back. Just realize there's going to be a little bit of that as far as going a certain direction, needing to maybe go back, retrace our steps, and try something else.
Does it say absolute? Does it say absolute or
Absolute. If it passes the absolute convergence of testing the absolute value, then we can say absolute convergent. But then some of this, guys, as far as testing the absolute value, like it looks really nice and pretty in a card, but it means going and doing the integral test, or it means going and doing a direct comparison or limit comparison test. Like sometimes testing the absolute value will take some time because you don't know right away. I've only done an easy one so far. But alternators can be on any sort of complicated function where this might take time to check that absolute value. If you go checking that absolute value and you're like, well, that doesn't tell me anything because it's not absolutely convergent, well, it still might be conditionally convergent. So, I don't know. It's a give and take. I think we should be pretty close to me being able to get that second example up for us to hopefully finish off before we're done. Okay, so then this one. This one, depending on your skill with the test, you might be like, okay, well, I could right now start testing for the 2 different sets of alternating series, and I could be seeing if the alternating series is convergent or divergent, done. And if I needed conditional or absolute, okay, fine, then I would take this guy, the absolute value, and take him off to my integral test, my p-series test, my direct comparison test, my limit comparison test, and think about it that way. And then come back and compare. But hopefully, even if you did take this guy off to the side, whether you're taking him into the alternating series test or whether you're taking him off to the side, hopefully you realize both of them should start with the nth term test. And why am I saying, or why am I bringing up the nth term test? Because what are we about to see if we start off with the alternating series? We have something that is not 0. What would have happened if we had thought about the absolute value and we hadn't been following the alternating series test and we had taken them over here? Hopefully you would have started with the limit for the nth term test. So either way, whether you started alternating series or whether you thought about absolute and ignored the -1 altogether, either way, hopefully you realize this guy is divergent, divergent, divergent. We can just say technically by nth term test. That's okay because we have a limit other than 0. So he's an exception to either way you start. As long as you always start with nth term test, you should be able to get divergent really fast and really quick. But what if we had something a little more like, oh, those are easy, those are easy. What if we had something a little bit more like this guy? Nth term test. You know nothing. So we'd have to go do an integral test or a p-series test or a comparison test. Over here, alternating series, we could just check 1 and 2, and if both of those pass, we know convergent, but we don't know which one until we take him to the other test. All right, guys, we're going to practice this tomorrow, and pretty much all tomorrow is the workday on alternating series test and getting a feel for, okay, I see it's alternating. Now what? Bye, guys.
Yeah, I want my shadow.